Hey everyone. Hey Rishi. How's it going, man?
Hey Noah, I'm doing great. How are you?
I'm doing awesome. I want to thank everyone for joining us on this fine Thursday morning, afternoon, wherever you are. I'd like to introduce myself. My name is Noah Wood. I am a product manager in the Azure Virtual Machines sizes team. I work specifically on the ARM-based VMs, which we're going to talk about a little bit later. Rishi, why don't you go and introduce yourself?
Sure. Thanks, Noah. Hey, everyone, good morning. My name is Rishi Gumbatam, and I'm a product manager for Azure Virtual Machines in the Azure Compute team as well. So super excited to be here with everyone today and hope everyone has had a fantastic morning so far.
Yes, sir.
So also wanted to introduce our awesome moderator, Amar. Amar will be in the background monitoring the chat and answering any questions you all may have during the duration of the session. We want to keep this as conversational as possible, so feel free to ask any questions you have, and we'll try to get to as many as we can throughout the session.
Yeah. So, what are we going to be doing today? Well, today the topic is creating a Linux virtual machine in Azure. So, we're going to go over what a virtual machine is, the different considerations and decisions that you need to make when you are trying to deploy a Linux virtual machine. We're going to talk about SSHing into the machine, going to talk about network configurations, storage options, and this is going to be kind of like an intro level course. You don't need to have a whole bunch of background on this. We're going to be covering all of that. Rishi, do you want to go over the kind of the logistics of the session today?
Yeah, absolutely. So for today's session, we will be following the Live Learn module, which can be accessed by going to this link on the screen, aka.ms/learnlive2022-1208A, or by using the link in the bottom left-hand corner of the screen, which is the QR code where you can also access the Learn module. So essentially, the Learn module will give you more background on the topics that we're going to be covering today, as well as it enables you to use what we call the Learn Sandbox. So the Learn Sandbox is a temporary session that you'll be able to activate so that you can access the Azure portal and create virtual machines free of charge for the purposes of having a hands-on experience for the demo in this session. So by using the Learn Sandbox, you'll be able to complete the exercises today along with us if you're interested in following along that way. And all you need to do to activate the sandbox is have a Microsoft account, and then you'll be able to use the Learn Sandbox subscription to create virtual machines free of charge for windows of up to 1 hour at a time. And since this session is going to be longer than 1 hour, we do recommend waiting to activate your sandbox until we get to the actual demo portion of the lab, so we don't actually run out of time here. And additionally, as Noah mentioned, this is a intro level course for creating Linux virtual machines in Azure. So there is no prior prereqs required for this session, and anyone can join regardless of your experience with virtual machines or with Azure.
Awesome. So Rishi, what are kind of the goals of our session today? What do we want our viewers to learn?
Yeah, so firstly, we want to understand the options that are available for virtual machines in Azure. So we'll cover the different types of virtual machines available on Azure, when to use certain virtual machines for certain types of workloads, as well as how to configure a virtual machine across key compute, networking, and storage configurations. We'll also then walk through different CPU architecture options, how to choose the right operating system for your VM, and how to create and use SSH keys to actually connect to your virtual machine. And after that, we'll move into the demo portion of the lab. So the first half is going to be talking through some of the different options that we have here, but then we're going to be moving to the demo portion of the session where we'll create an actual Linux virtual machine using the Azure portal, connect to that virtual machine using SSH, and be able to actually install and configure the virtual machine to run as a web server. So overall, after the session is over, hopefully you are all able to understand how to choose the right virtual machine and the actual steps on how to create and configure your virtual machine to start building and running applications in Azure.
Thanks, Rishi. Yeah, so just we want to preface this by saying that we're going to be going in a little bit different order than the Live Learn module. So we're going to be covering all of the background material, all of the learning material that's required for the exercise first. So what is SSH? What is a VM? The storage options, the network configuration options. We're going to cover all of that first, and then we're going to hop into the exercise and do all of it in one fell swoop. Now, a lot of this content was in a similar session last week. It was called Introduction to VMs. Now, they used a Windows VM for their session. So if you were able to join the session last week where they talked about Introduction to VMs in Azure, some of this content might be the same to you. So we're just going to run through the background material quickly. Maybe some of you already know what a VM is, and then we're excited to get into the demo. So Rishi is going to get us started with the content, starting off with virtual machines.
Perfect. Thanks, Noah. So starting with, what are Azure Virtual Machines? So Azure Virtual Machines, or VMs, are on-demand, scalable cloud computing resources. So what does this really mean? So you can think of VMs very similarly to your computer, just like your laptop or your desktop. Your computer will have a CPU, it'll have memory or RAM, it'll have some sort of storage, whether that's a hard drive or a solid state drive, and it'll have a networking card so that your computer can connect to the internet or other local networks. But instead of that computer running applications and tasks on the physical hardware of your laptop or your desktop, Azure Virtual Machines enable you to get that same combination of hardware resources, CPU, memory, storage, networking, but as a part of a virtual computer running on servers inside Azure data centers. So imagine if your company was running any application on a server on premises. Azure Virtual Machines enable your company to run that exact same application on a virtual machine in Microsoft Azure on a similar set of virtual hardware resources. And overall, this is super powerful because it enables you to firstly not have to worry about the really low level details of managing the underlying hardware for these virtual machines. So in general, Azure will take care of things like firmware updates, hardware maintenance, and just take overall a large portion of the management aspects away from you and manage that within Azure itself. And secondly, using virtual machines in Azure enables flexibility and scalability. If there is a surge in demand for your application, Azure Virtual Machines are enabled to scale seamlessly up and down to meet this demand. So you don't need to go ahead and procure or provision physical servers months in advance to meet any slight changes in overall demand assumptions, but instead could leverage the large scale of Azure data centers to meet the computing requirements of your workloads by leveraging these virtual machines. And then finally, Azure has a pay-as-you-go model. So if you no longer need the resources of your virtual machine, you can stop the VM and you only pay for the resources that you use. So now that we've talked about what virtual machines are, Noah, what are some of the different types of CPU architecture options available for customers using Azure VMs?
Thanks, Rishi. Yeah. So one of the first decisions that you're going to have to make when you are choosing your virtual machine is the CPU architecture. So in Azure, we have two options. We have x86 and our newer ARM64. So most of you are probably familiar with x86 based CPUs. They're in most laptops today. In Azure, we have both AMD and Intel CPUs powering our general purpose machines. And then on the ARM side, we've recently introduced our ARM-based VMs in Azure. So you may not be familiar with ARM, but you probably do have an ARM device in your possession. ARM chips power most mobile devices and IoT devices. And in recent years, they've become more powerful, and we're now able to build these into servers and bring the benefits of ARM to the cloud. So the ARM-based VMs are engineered to efficiently run scale-out, cloud-native workloads while offering outstanding price performance. So the ARM VMs do have a different CPU architecture, but they will mostly feel and function the same as what you're used to with an x86 VM. All of the key popular Azure features like the portal, the CLI, which we're going to be talking about and covering later, they're all going to be supported on ARM seamlessly. And so we aim at offering our customers as many options as possible to fit their workloads needs. So with now x86 and ARM, you can choose the CPU architecture that's going to make the most sense for your scenario and your use case. And we're excited to be demoing a ARM VM in the Linux VM deployment today. So now that we've covered kind of the background CPU architecture, that kind of first decision that you need to make when you're deciding what VM you want to deploy, Rishi is going to go over the different scenarios and VMs for those scenarios.
Sounds good. So this slide overviews the different types of virtual machine families that are offered within Azure. And really the goal here is to really have a gamut of product offerings that meet a diverse set of customer workload needs. So ranging from our entry level and burstable families that target mainly smaller databases or web servers and are generally lower end compute machines, all the way to our compute intensive or GPU accelerated or high performance computing virtual machines, which are super powerful computational machines. Azure aims to offer virtual machine solutions that enable customer choice across a large variety of workload requirements. And to reiterate what Noah mentioned just now, a little bit earlier as well, we are starting to enable more choices of CPU architectures for customers, including having now the ARM-based Ampere CPUs in our general purpose and memory-optimized VM families. And moving to the next slide. So to go a little bit deeper into what workloads map well to each of the VM types, the first category here is essentially our general purpose compute. So if you need a good balance of compute resources, memory, and networking for workloads, like hosting a web server or a small database, our A, B, and D families of VMs offer a variety of different options that satisfy the general purpose compute category of workload. And in our demo session later on, we're going to be spinning up a DPDS v5 ARM-based VM to act as an Apache web server, which is a great use case for using a general purpose D-series VM as well. Moving down the list, we have our F-series VMs, which are going to be focused on workloads that need a higher level of compute compared to our general purpose VMs, such as for gaming or application servers. So these F-series VMs offer CPUs with higher clock speed and are good for these compute-intensive applications. Then we have our large memory VM, our E and M VM families, which are good for big databases that store a lot of data in memory itself. As well as our L-series family of VMs, which are good for databases that need high I/O speeds and throughput to fast local SSDs directly on the platform. And then finally, we have our large accelerated computing VMs, which are our N-series VMs, which have a GPU attached to them, which can accelerate things like graphics renderings, as well as training and inferencing for deep learning workloads. And lastly, our H-series VMs, which are designed to have extremely powerful CPUs and very fast networking interfaces for those high-performance computing applications.
Yeah, thanks, Rishi, for covering the different types of VMs and their fits for different scenarios. I just want to cover kind of the naming conventions a little. It might be confusing to some of you if you're new to Azure. So starting out with the capital letter in the front of the VM name, that's going to refer to the family. So for our general purpose, our A is going to refer to the entry level, the B is for a burstable VM, and then the D is the standard general purpose. Then we've got F as the compute optimized, and then E and M as the memory intensive. Then moving on, we've got the L is the storage optimized, and then N and V for the GPU and high performance computing respectively. And then all of the other letters in the name, the subsequent letters, so the P in the case for the DPDSV5 series, the P is going to refer to the CPU architecture. So for your DA series, you've got an AMD CPU in there, and then for the DP, you've got an ARM CPU. The next D in there is the local disk identifier. So this VM has a local disk, a temp disk attached to the VM. We're going to be talking about that a little bit later. The S is going to refer to premium storage. And then the V5 is just referring to the generation of the VM. So now that we've kind of given an overview on the different VMs that you have to choose from, Rishi, I already talked about how I work on the ARM VMs. What VMs do you work on?
Yeah, so I'm the product manager for the L-series VMs, and we recently launched the LSV3 and LASV3 VM families earlier this year. And these are going to be great virtual machines for pretty much any of your big database workloads that rely on high I/O and high throughput directly to those fast local attached SSDs. So if you have a database workload that fits some of those requirements, go ahead and check out the L-series VM family, which are now live in a handful of regions. So please go to the portal and look at that if you're interested. Okay, so now that we've covered the different types of virtual machines that are available within Azure, I think we should talk a little bit about how to actually deploy a virtual machine. So Noah, what are some of the different options available for customers on how to actually deploy a VM on Azure?
Yeah, so there's a whole bunch of options. There's some options that are not even going to be covered here, but the main three options are going to be the Azure portal, which is the UI that you can go use and deploy a VM through walking through the different screens. That's what we're going to be doing today. Up next is a script, so the Azure CLI or PowerShell, which is going to be a little bit faster, a little bit more agile. It's typically more experienced Azure users are going to be using the CLI or PowerShell. And then finally, you can use an ARM template, which is a JSON file where you can configure your deployment down to the T, and then upload that ARM template into Azure to deploy your VM in the configuration that you wanted it.
So Noah, as someone who's no doubt deployed hundreds of VMs in your life, what is your favorite way to deploy a VM, or one that you use the most often?
Yeah, so I tend to be using the Azure CLI a lot these days. Like I mentioned, it's the most agile option. And so while the portal, it breaks everything down for you, it's very easy to tell and walk through the different steps in the deployment process. Once you kind of have that baseline level understanding, the portal is going to tend to take a little bit longer than the Azure CLI. So if I know exactly what I want to deploy, I can go into the Azure CLI, write that command, and then within probably a minute or so, I can have my VM up and running. So that's typically what I use when I'm deploying VMs.
Gotcha. Yep, that makes a ton of sense.
Yeah. So we've kind of talked about how to deploy a VM. Next up, we've got to talk about what image you're going to use when you're deploying your VM. So first off, what is an image? The easiest way to think of an image is that it's basically an operating system just for your VM. So the Azure Marketplace provides pre-configured images that include both an OS and common software tools installed for specific scenarios. So if you want to tailor your image down to the T for your use case, you can also create your own image and utilize the Azure Compute Gallery feature to store that image in Azure for your VM deployments. So while the marketplace is a great tool, it's not the only option available for you. Like I said, you can create your own custom images for your use case and then deploy those VMs with them too. So just a quick hint, this might be one of our knowledge checking questions that we're going to cover later on. So maybe remember that tidbit about custom images. So since the focus of this session is going to be on Linux, let's talk about the Linux images available. So you may be surprised to hear that Linux makes up the majority of the images available in the Azure Marketplace today. We're proud to have such a wide array of Linux images to use from. The Azure ecosystem has expanded rapidly around Linux and open source solutions in general to support organizations of any size. The Azure Marketplace solutions contain Linux and open source offerings from industry's most influential organizations, in addition to a broad variety of niche solutions from vendors of all sizes. So we've kind of covered what a VM is, the key considerations, including architecture and scenario when choosing a VM. We've also covered how to deploy that said VM and then the image options available to do so with. Up next, Rishi is going to talk about the resources that go into this VM that we're going to be deploying.
Yeah, sounds great, Noah. So as we discussed previously, a virtual machine has different components to it across compute, storage, and networking. And we'll now spend a few minutes discussing what is important across these components when it comes to actually creating the virtual machine. So the first, which we've already covered, is compute, which is essentially your CPU and memory resources. The second is storage, which can manifest itself in different ways as it relates to a VM. You first have your storage account, which essentially holds all of the disks associated to your account in one spot, and the actual virtual disks, which contain the OS images and can store the data from your virtual machines. And then finally, we have networking, which enables the virtual machine to be set up to both communicate with other virtual machines inside your virtual network, as well as how the VM can communicate with the internet by configuring a public IP address for your VM. So we'll go a little bit deeper into each of these categories in the coming slides, as it is very important for understanding how to configure the settings of your VM correctly, and will be important for when we actually create a virtual machine in the portal later on in the session.
Awesome. Yeah, so up next, I'm going to talk about kind of the first part of what Rishi was discussing with the resources when you're going to be deploying a VM. So up first is storage. So storage is arguably just as important as the decision for what type of VM you want to deploy. Here in Azure, we have many features and capabilities to allow customers to maximum fine tune their performance and their storage costs. So as this is kind of an intro level course, we're going to keep this description light when we're talking about storage. And you can find more details about the different storage options in the Azure documentation and live learn. So storage generally is going to fall into two main hardware categories. First, we've got our standard hard disk or hard drive. That's going to be the cheaper option. And then if you want a little bit more performance, you can opt for a premium SSD or solid state drive. With the premium solid state drives, you can opt for either premium SSD V1 or the recently launched premium SSD V2, which gives you even better performance. And then if you're looking for the top of the line performance, maybe for your production workloads, you're going to want to go with the ultra disk storage options. So now that we've covered kind of the hardware that's backing storage, Rishi is going to walk us through how storage maps to the different hardware disks.
Yeah, so when you actually mapping your storage options to disks, Azure uses what are called virtual hard disks or VHDs that essentially are virtual versions of physical disks, but stored as page blobs in an Azure storage account. And by default, two virtual hard disks will be created for your Linux VM. The first being an OS disk and your primary drive. So this will be like your C disk on Windows and will be the default place that OS images are stored. And the second is a temp disk, which provides temporary storage for OS page files or any other apps running on the virtual machine. So do please note that there are some VM sizes that do not actually have a temp disk, which is usually noted with a lowercase d nomenclature in the Azure virtual machine name. But for the VMs that do have a temp disk, these will automatically be mounted onto the virtual machine by Azure. But also please note that the temporary disk is in fact temporary. So any file stored on the disk will be lost once the VM is deallocated. So this is a good use case for example, storing OS page files. But also please make sure that the data that you want saved persistently is not only stored in the temp drive, but is backed up and stored in some sort of persistent storage.
Yeah, so up next, Rishi is going to kind of dive into networking. So we've already covered VMs, images, how to deploy them, then storage, and now finally networking. And then there's one more piece before we get into our demo. So why don't you start us off with what a network security group is, Rishi?
Sure. So on this slide, we'll talk a little bit more about network security groups or NSGs. And NSGs are the primary tool used to enforce and control networking traffic rules. But to take a quick step back, when you first create your VM, you will first set up the virtual machine in a VNet or virtual network. And virtual networks enable all of your Azure resources, including virtual machines, to securely communicate with each other, similarly to a network on-premise. So anything within the VNet will have certain rules on what can be communicated within the network, as well as what communication is permitted with items outside of the network, such as the internet. So within the box of a virtual network, you can also enable subnets, which are essentially sub-networks within your virtual network, so that you can further segment your network and assign specific network security rules to each subnet as needed. And that way, if you have different security protocols needed for certain VMs, but not for all of your VMs, you have the ability to create multiple subnets with different networking rules and assign those resources to the subnets accordingly. So going back to network security groups, these are the tools that actually enable you to enforce and control the network traffic to your VNet and your subnets. And these network security groups have rules which enable you to allow or deny traffic moving through your network accordingly. So in the next few slides, we'll talk a little bit more about how to plan your network communication and the actual network security group rules for virtual machines. So as we discussed on the last slide, virtual networks lets you define how your resources communicate with each other and external resources. And when you're first creating a VM, the first thing you're going to want to do is look at how you want to map your network holistically. So when you first create a VM, you have the option of creating a new virtual network or using an existing virtual network in your region. So for the purposes of our demo, we will be creating a new virtual network. But if you, for example, already have 5 virtual machines up and running in an existing VNet and just want to create a 6th virtual machine, you can easily add that VM to an existing VNet as well and aren't required to create a new VNet. So Noah, do you want to talk a little bit more about how to actually configure your network settings and how to set up networking rules for a VM?
Sounds good to me. Yeah, so in Azure, similar to VM deployments, we allow customers multiple different ways to change their network topology. So you might recognize the different options available there. You can do it through the portal, through the CLI, or through PowerShell tools, or even with ARM templates. And so when you create a VNet, it's initially going to be locked down such that no outside resources can access that VM except for different resources inside the same VNet. But the way that you're going to be able to open that VM up is by opening up ports. Rishi, if you want to go to the next slide. Thanks. So yeah, like I said, by default, the ports are going to be locked down when you deploy it, as long as you're deploying your VM with kind of the basic network security group settings, with the exception being other resources inside that same VNet can talk between each other, and then Azure itself with the load balancer can talk to the VMs as well. So if you want to turn your virtual network into something that's able to communicate with the outside world, you're going to have to change your network configuration and open up some VM ports to allow traffic in. So the way that you're going to do this is by changing the firewall rules, Rishi. Yeah, thanks. So you can think of your firewall as just being controlled by your network security group, which Rishi already covered. So you update your network security group settings by creating a new rule, which says, okay, I'm going to allow this specific type of traffic through this specific port at this level of priority. So it gets a little bit confusing, but we're going to walk through this when we do the demo. So hopefully it'll make a little bit more sense there. But yeah, essentially, you're going to have your basic network security group settings from the get-go. When you deploy your VM, it's not going to allow any traffic in. It will allow outbound traffic because that is low risk traffic. But if you want to turn your virtual network into something that's a little bit more of a production style and open up some ports, you'll change your network security group rules to allow traffic through specific ports. Like for example, HTTP traffic in port 80. So that's kind of the summary of the network configuration settings. Obviously, you can get a lot more detailed here, but again, this is an intro level course. So finally, Rishi is going to walk us through what SSH is, and then we're going to jump into the demo.
Perfect. Thanks, Noah. So the last topic we want to cover before jumping into the demo is SSH. Secure Shell, or SSH, is an encrypted connection protocol that allows secure sign-ins and operations to your VM. So from a terminal, you'll be able to use SSH to log into virtual machines with an encrypted connection. So you can set up SSH with either a username or password combination, or with a public key, private key pair. In general, we don't recommend using the username or password only because it would leave you more open to a brute force type of attack. The public key, private key pair is an option that is better and that we recommend, where essentially you'll be able to create both a public key and a private key, which the public key can then be associated with the virtual machine and then attested with the private key once you're actually able to connect with the SSH protocol with the machine that you're connecting to the VM with. So additionally, with the public key, private key option, you have the option to add a password as well, so that if a bad actor, for example, is able to access your private key, they would still need the password to be able to SSH into the VM. So it just gives you an additional level of protection there. So now that we've talked about pretty much all of these things, we're going to actually dive into our demo. So Noah, do you want to talk us through what the next steps we're going to perform within the portal are?
Sure thing. So if you've been following with us along the live learn presentation, you've probably seen some of these exercises already. So up first, we're gonna decide an authentication method for SSH. Once we figure that out and we have our SSH key, we're going to create a Linux virtual machine with the Azure portal. Again, we're going to be deploying an ARM-based VM here. Now, I do want to say that if you're following along with the live learn module, you're going to be operating in that Azure sandbox, and there is a scoped down list of VM sizes that you're going to be able to deploy, and the ARM VMs are not one of them. So if you go create a free Azure account and you want to try out the ARM-based VMs, you can certainly do that after this exercise. But if you're following along with us with the sandbox, you're not going to be able to do the exact same thing as us. For the most part, it's going to be the same though. So after we figure out what VM we're going to deploy and we deploy it, we're going to try to connect to that VM with SSH. And then once we're into the VM, we're going to try to turn it into a web app that's serving web server pages. And that's going to require us to configure the network settings. So we're excited to jump into the demo. And I think, we can probably switch over to my screen now. Let's see if we can get that done. Awesome. Cool. So we've got my screen up now. I'm going to be walking us through the demo. So Rishi, if we want to do the SSH keys, what's up first for us?
Yep. So I guess before we dive into the SSH keys a little bit, just wanted to give an introduction to what the Azure portal is. So what Noah is sharing right now is what the Azure portal homepage looks like, which essentially gives you just a visual representation user interface for all of the different options you have within the Azure services umbrella. So if you want to do anything within Azure, the portal is a great place to start, and it gives you a good view into all of your resources in one spot. So the first part of this exercise is going to be actually generating our SSH keys that we're later going to be able to use to remote into our virtual machine. So the first thing that we're going to need to do is pull up the Azure Cloud Shell, where we can actually issue bash commands to create these keys. So Noah, if you go to the terminal window on the right side of the search bar and click that icon, we should be able to pull up the Cloud Shell terminal.
Gotcha. Okay, pulling it up now. We can see that it's loading here at the bottom. You could think of this as basically a command line interface just for Azure. So you can use the CLI in here, and it's a really great tool. It's pretty seamless. So what's up first? What do I need to do if I want to create an SSH key?
Yeah, so the first thing you're going to do is run the SSH keygen command. And what we're going to do is use the RSA public key algorithm and set it to size 4096. So this step will essentially create our public and private keys. And this is the command that we're going to use to do that.
Okay, so it's asking me the file that I want to save the key in. Do I have to change anything here?
No. So by default, if you can see the folder path that's in Noah's command, home noah.ssh/ID RSA, this will be the default location in which your public and private keys will be stored. So if you want to put this in a different file location, you can specify that in this step as well. But for the purposes of this demo, we're going to accept the default location. So Noah, go ahead and just press enter and we can move forwards.
Awesome. So it looks like I already have an SSH key saved in this default location. So the CLI is going to recognize this, and it's going to ask me if I want to overwrite that key. So while saving your key in the default location is going to make it really easy for the next steps of our exercise, maybe most of the time you have a bunch of VMs, you're going to want to save your keys that you need to access these VMs in a a shared location or a location where you can easily find them, so that you're not overwriting them when you're trying to save them in the default location. But for the purposes of this exercise, it's fine that I put the key in the default location. So I'm going to go ahead and select yes to overwrite. Okay, so now we see that it's asking me for the passphrase. So Rishi kind of touched on this a little bit earlier. SSH is a great secure way to allow you to get access into your virtual machine. And the added layer of security here is going to be with this passphrase. So like Rishi mentioned before, the passphrase is just going to be, it's going to protect you from the scenario where, let's say you accidentally share your SSH key among a broad range of people. They're still not going to be able to use that key to get into the VM that you've deployed linked with that SSH key because they don't have the passphrase. So I'm going to choose a passphrase here. Hopefully I don't mess up the typing. And it looks like, did that work, Rishi?
Yep, that does. And there's a easy way to check this as well. So what we just did was we created a public key and a private key into the key path that we had talked about earlier, the default location. So what we can do is actually use the cat command to go to that same location and look at the public key to verify that it worked. And we're going to need that public key for later when we actually create the VM.
So I'm entering the location here and I see a big string comes up.
Yep. So we're going to want to copy paste that. That's exactly how it should look. And that is our public key to our SSH. So we'll be able to copy this to our clipboard and we will actually use it in our next step when we're creating our virtual machine, so that we'll be able to use that public key and the private key that we've saved in the same folder to be the attestation to actually enable that SSH connection for our VM.
Awesome. Cool. So what's up next? We want to deploy our virtual machine, don't we?
Yep. So the next thing we're going to do is actually create the virtual machine. So why don't you go ahead and click on that big plus create a resource button on the top left of your screen.
Cool.
Yep. And here is the way to create any type of resource you want within Azure. So there are a variety of different things you can create, from virtual machines to functions to databases, etc. And you can also use that search bar at the top to find anything that you want to create. Virtual machine is the first one on this list. So why don't we go ahead and create a virtual machine by clicking that link?
Sounds good to me. So why don't I walk us through kind of this create a virtual machine page. So if you're following along with us, the first option or first step is choosing the subscription. So as we can see here, we have the ARM64 non-prod. That's my own personal team's subscription. If you're doing the live learn module, you're going to have a different subscription showing up there. You're going to want to select that live learn sandbox subscription such that you can deploy VMs. Up next is the resource group. So you can think of the resource group as kind of a folder that's containing all of your Azure resources. So I'm going to create a new resource group for the purposes of this exercise. Why don't we call it Live Learn NWRG, NW being my initials. Does that sound good
are also
to you?
my initials, so I know that's not what you meant it, but it worked out.
Of course. Up next, we've got the virtual machine name. So why don't I name this Test Web West US2, if I can spell correctly, West US2 ARM64 VM. Does that look good to you? Yeah, I think that's good. So yep. Typical naming practices, you're going to want to have a bunch of identifiers in your VM name. So here I have a test, which is kind of the environment, the web, what we expect this VM to be doing, the region, which is the region that I'm going to be selecting for deployment, and then following is just kind of a name of the VM, the ARM64 VM, like what it is. If you don't name your VM in an identifiable manner, it's going to be challenging for you when you're sorting through all the different virtual machines that you've deployed in your experience with Azure. I know I have faced this issue many times. A lot of the time, if I'm just rushing through, I'll just call it VM1, right? But if I have a bunch of VM1s, it's going to be really hard to identify which VM1 is actually running my web server, right? So make sure that you put some thought into your VM name. Up next, we've got the region. So in this case, I think West US 2 is fine. Does that sound good to you, Rishi?
Yep. You want to choose a region that's close to you in general. So West US 2 seems like a good one, but you have a variety of different options available depending on where you're located.
Cool. Yeah, West US 2, I believe, is in Washington, and we're both located in the Redmond area here at the Microsoft campus, are working from home, but still in the area. So for availability options, we're not going to dive too much into what availability options is going to do for you, and we're going to keep it as no infrastructure redundancy required. But I'll open this I bubble, and essentially what the availability options are is that it's going to allow you to integrate more resiliency into your virtual machine. So if you want to deploy your VM such that it's going to be protected from, let's say, a planned maintenance or an unexpected outage or an interruption, if you deploy your virtual machine in what's called multiple availability zones, you're going to be protected from those outages such that the VMs in the backup availability zones can step in when the initial VM has some interruption. So for the purposes of this demo, I think it's fine that we don't have extra resiliency on our VM, but that's certainly an option available to customers for their more production-like workloads. For security type, we're just going to keep it as standard. And then here is kind of where we get into the difference in deploying an ARM-based VM versus an x86. So you can kind of already see these radio buttons, but we're going to start with the See All Images button because we want to choose an ARM64 image. So now I've kind of opened up the Azure Marketplace. It's loaded. We see some Windows Server, Windows 10 images available to us, as well as some Ubuntu images. So if I want to deploy an ARM64 VM, which has an ARM64 CPU, it's going to need an ARM64 image. So I can select that by going to image type and filtering on ARM64. And how about we just choose the Ubuntu Server 1804? Does that sound good to you?
Yep, sounds fantastic.
Okay, so now that we've selected this ARM64 image, it's changed the VM architecture to indicate ARM64 as well. Now we want to choose what ARM64 VM size we want to deploy. So the cool thing about Azure is that it knows that I've just selected that ARM64 VM size. So when I choose select all sizes or see all sizes, it's only going to show me ARM64 VM sizes. And like we talked about earlier, those are going to be designated with that P suffix. So I think as we discussed, you said we're going to be deploying a DPDS, right? How about let's choose a D4 PDS V5. This is going to be a 4-core or 4 vCPU, 16 gigs of RAM, local disk enabled virtual machine. And this is in the general purpose family. So we've got the size, we've got the image, we've got the region. I think we're all set up top here. Rishi, what should we do about the SSH aspect of this screen?
Sure. Yep. So as you remember in the first step of this, we created our SSH keys. So now what we want to do is enable our virtual machine to be accessed using the SSH public key that we created. So as you can see here under authentication type, you also have the ability to set it as a password. But as we discussed earlier, the public key, private key is the more secure option. So we're going to go with the SSH public key.
Gotcha.
So with SSH public key, you're going to need a username password combination as well. So why don't you go ahead and put something that identifies yourself? Perfect.
Sure.
Okay, and then on the next step, we're going to choose the SSH public key source. So there are a variety of options here. We can generate a new pair, we can use a key stored in Azure, or use an existing public key. So since we already created our public and private keys, we can go ahead and select that last option, which is use an existing public key. And what we're going to do is copy and paste the public key that we copied in the last step directly into here. And that will associate the VM from now on with this particular public key. And then when we want to remote into it later, we will be able to provide the private key location to do the full attestation to establish that SSH connection.
Gotcha. Do I need to change anything about the inbound port rules, or is this good to go?
Yeah, so the default setting here is that the public inbound ports will be set to none and pretty much only enable you to be your VM to be accessed by other virtual machines or services within your virtual network or through a load balancer. So whenever we actually enabled this virtual machine to be enabled with SSH, it actually automatically went in and selected the SSH port as having the ability to connect to our virtual machine from an inbound connection. So as you can see here, when we allow the selected ports for SSH, that will be on port 22, and we'll give the SSH protocol permissions to actually access our virtual machine from an inbound connection and create that connection so that we can remote into it and perform operations.
Awesome. So since this is already set to the inbound port SSH at 22 being enabled, we don't need to change it, right?
Correct.
Okay. Should we go on to the disks page?
Actually, scroll up for 1 second. One other thing I wanted to hit on as well. So keep going up to the top of the screen if you don't mind. So just whenever we look at the different steps to create a virtual machine, there are 6 or 7 different categories up top in which we can go and make adjustments as needed. So for the purposes of most virtual machines, you really only need to be touching the basics, disks, and networking tabs, which is what we're going to be doing in this demo. But there are other tabs such as management, monitoring, advanced tags, etc., that give you a lot more configurability to choose the settings that you want for your virtual machine. So we'll be going through disks and networking, but in general, we don't change a ton of settings here for the rest of the tabs. So why don't you go ahead to the disks tabs and we can go from there.
Awesome. So why don't you tell me what this disks tab is telling me? What are the options here?
Sure. So as we discussed earlier in this session, there are a few different types of storage that can be attached to your virtual machine. The first is the OS disk, which we see here. And the OS disk will essentially have the OS image that we actually chose earlier. So the Ubuntu 18.04, that's where the OS disk is going to be stored. So this is going to be they have a few different options. We're going to leave these all the same, which is the premium SSD locally redundant storage, and keep everything else the same on this OS disk. And then there's 2 other disks that we talked about as well. One of them is the temporary storage, which we actually, since we chose the DPDS v4 VM, D4 PDS v5 VM, the D nomenclature in that virtual machine means that our virtual machine is enabled with temp disk. So it's not going to show up on this tab, but whenever we get into our VM, you're going to see that it's going to have a temporary disk already attached to the virtual machine. And then the last thing is going to be our data disk, which will pretty much be a disk that's in remote storage in our storage account. So this is going to be a persistent disk that we can also create and attach to our VM. And whenever the VM is deleted or deallocated, this data that we want to store on this disk will remain persistent. So why don't we go ahead and create and attach a new disk that we can attach to our virtual machine?
Sounds good. Okay, do I need to change anything here?
Nope. So everything looks good here. It'll automatically create the name of your data disk based off of the name of your virtual machine. And this is going to be 1,024 gigabytes, or around a terabyte disk that we're going to be attaching to our virtual machine. So I think we're good on this section. Go ahead and click OK.
Okay.
Yep, and there you can see it on the bottom. So it's attached to our virtual machine, and we should be good on the data disk.
Okay. Sounds good. Should we go to the networking tab then?
Yes, let's do that.
Cool. So just a quick pointer here. You can navigate the portal multiple ways. The first time we just selected these top tab buttons, but if you want to go cycle through one by one, you can click the bottom, next, and previous. So Rishi, why don't you walk us through kind of the VNet and the networking options available to us?
Yeah, sure. So as we discussed earlier in the session as well, one of the first things you want to do is create and plan out your networking structure for your virtual machine and how it fits in with the rest of your virtual machines or other services you have within Azure. So since this demo is standalone, we're going to be using a new virtual network, and you can see that new in parentheses. So it'll automatically assign a new virtual network, but you do have the option to use an existing virtual network if you're just simply adding another VM to your overall like Azure structure if you already have that created. And by default, we'll also have a subnet. And remember, subnets are just subsections of the virtual network that you can assign different security rules to as needed. It will automatically put us into a new subnet. But again, similar to a virtual network, if you have an existing subnet that you would want to assign this virtual machine to, you have all of that configurability options here as well. And then from a public IP perspective, we'll also be able to create a new public IP address to access the VM from the internet if needed as well. So we're actually not going to change any of the configurations on the networking slide, but you can also see here that the SSH that we discussed on the basics tab will show up here as well as a inbound port that is enabled in our network security group rules to access the virtual machine with an inbound connection.
Awesome.
And I think for the rest of these, we should be good. You want to keep accelerated networking enabled. And yep, we don't need to change any of the other settings. And we should be able to go ahead and click review and create. So as we discussed last time, we don't need to go through the management or tag section. You are able to do that if you want to, but for the most part, we will just be skipping those for this time and going to the review and create button, which should deploy our VM.
Awesome. Yeah, so just as a quick recap here, we're going to be creating a new virtual network and a new subnet and a new public IP for our virtual machine because we're doing this all for the first time for the purposes of this demo. But let's say you have a production environment, you have a web app or a combination of a bunch of VMs that are already in one virtual network, and they all have maybe they're abiding by a network security group that has some specific rules, right? In most cases, you're going to be deploying a VM and then connecting it to that virtual network. So we are creating our new virtual network, but most of the time you would be choosing a network that you've already created, and then you don't have to worry about changing the network security group rules all over again once you deploy your VM. So like Rishi said, we're not going to be changing anything here. We can move on to the review and create page. We'll see if it loads here for us. It's running validation. It looks like the validation has passed. That's a good sign. We can see how much our VM is going to cost us. We can see that the SSH port is open. If you want to see more details about the virtual machine, what you're going to be deploying, you can go scroll down, make sure everything checks off to you. And I think we should be good for deployment. Does that sound good to you, Rishi?
Yep, it sounds great. So go ahead and click that create button on the bottom left, and it'll start our VM deployment.
Awesome. So deploying a virtual machine, unfortunately, is not instantaneous. It's going to take some time for Azure to spin up this virtual machine for us. So in the meantime, while we wait for this to deploy, why don't we go over the first knowledge checking question? Does that sound good?
Yep. So if we can switch back to the PowerPoint, we can go through that first knowledge check.
Awesome. So this is going to be our first knowledge check question. If you want to answer the question on the poll, you can go to that https://aka.ms/polls08. Feel free to put your answer in the chat as well. If you don't want to go to the poll, you can also access the poll via that QR code you see there. But why don't we read the question? So true or false? For security reasons, you must use an image from the official Azure Marketplace when creating a new virtual machine. Interesting question. I wonder if we've covered this a little bit earlier. Maybe some folks maybe some of the viewers remember. But let's give it maybe a couple minutes or 30 seconds or so to let everyone answer the question either in the chat or on the poll. It looks like I see some votes coming in. Rishi, why don't you tell us what the answer is here?
Sure. So the correct answer for this question is B, false. So while the Azure Marketplace enables you a lot of pre-configured VMs with common distributions available to use for your virtual machine, it is not required to use a image from the Azure Marketplace when creating a new virtual machine. So you do have the option to upload your own OS image that is more configured to exactly what you want to use for your use case. And a really good common example of when this is useful is if you want to move something that you have on premise into the cloud and lift and shift it, you have the ability to use your pre-configured OS settings exactly like you use on premise and be able to upload that image and use that same image directly on Azure.
Awesome. Yeah, thanks, Rishi. I'm just reading a question in the chat here. I think I see that my VM has finished deployment. So why don't we jump back to the screen that we've got the portal pulled up and we can continue with the exercise. Does that sound good to everyone? I hope it does. So as we can see, we've got this green check mark saying our deployment is complete here. Should we go to the resource, Rishi?
Yep, let's go ahead to the resource page.
Okay, so why don't you tell us what this kind of overview page is showing us here?
Sure. So this is the default page for our resource, which is a virtual machine in this case. And in the Essentials tab, it pretty much gives you a very high-level overview of the status and key metrics for the VM. So as we can see under the status section, it is running in WestUS 2, and it gives us information such as the subscription ID, the operating system we chose, as well as our public IP address. And then throughout the rest of this page, we do have more information around the virtual machine, the networking, the storage attached, and it pretty much gives you the one-stop shop for all of the information about your virtual machine. So now that we have the virtual machine running, the next step we need to do is connect to the virtual machine. So Noah, why don't you go ahead and click that connect button on the top left of the screen and click SSH so that we can use the previously developed SSH keys to connect to our virtual machine.
Gotcha. Okay, we've got to the SSH page. What do we need to do if we want to connect to our VM?
Sure. So we're going to be looking at steps 3 and 4 here. So in our creation of our SSH keys, we provided the default path to our SSH private key files. So we don't actually need to type anything into this box. But if you did save your private key and public keys into a different folder or a different path, you can type that path in directly and it'll auto-populate the command in step 4. So the command in step 4 is the command that we're going to use in the Azure Cloud Shell Bash terminal to actually connect to our virtual machine. And it will auto-populate in the -I private key path with a custom path if that's where you chose it. But since we are going to be using the default, why don't you go ahead and copy this command directly, run it in the Azure Cloud Shell, and we'll just delete the -I private key path and be able to just connect to our VM with the IP address at the end.
Okay, so I'm going to delete this -I private key path, and then I should be good to go?
Yes.
Okay, how about I hit enter then? All right, it's telling me that the authenticity of the host and then my IP address can't be established. What is this telling me?
Yeah, so the first time you connect to your virtual machine via SSH, this step is pretty much just saying that, hey, you haven't connected before, so it's very normal. And by selecting yes, do you want to continue connecting, we'll just be establishing that this is going to be a known host that will connect to our virtual machine in the future. So very normal. Go ahead and click yes, and we should be able to move on to the next step.
Okay, and now I see that it's asking me for my passphrase. So hopefully I remember this passphrase. I've just entered it. And it looks like that worked. I believe it did. Let me scroll up to make this bigger. And how about I scroll up here? So previously I was in the location Noah at Azure. And that's where I was writing the commands to try to SSH in. But now it looks like I'm in Noah Wood at test web US West US 2 ARM64 VM. So it looks like I'm in my VM. Why don't I try to run a couple commands to see if this is actually working? So I'll try ls-la to show the root of the disk. It looks like that's working as expected. How about I try LSBLK. And this is going to show all of my devices. So, okay, it looks good. It looks good. I see SDA1 in here, SDA15. So SDA1, this is going to be my OS disk that Rishi covered previously when we were talking about how the storage maps to the different disks. So SDA1 is going to be my OS disk. I know that because of the size. SDA15 is going to be my boot drive. So what the VM, the different metadata that the VM needed to use in order to create itself or boot up. And then we've got our SDB, SDB1. So this is going to be our temp disk or our local disk. If you remember, we deployed a D4PDS v5. That second D there is going to indicate that we have a local disk VM. And as we can see in our ls block command, SDB1 shows our local disk there. Finally, I see this SDC that looks to be 1 terabyte, but I see that it's not mounted. Is this our data disk, Rishi?
Yes, it is, and you can tell that because, as we discussed as we showed in our previous step, when we created and attached our data disk, it was a 1 terabyte disk. So this definitely maps to that, and yep, it is not mounted. So the next step we're going to have to take is to create a partition and file system for that disk and be able to mount it.
Gotcha. Okay, so what command do I need to use to create the primary partition for this disk? Is it this echo one?
Yeah. So the command you're going to use is sudo fdisk, and you're going to create the partition for the dev SDC disk here, and then you're going to use the echo commands at the beginning to pretty much populate the parameters that we want for our partition. So why don't you go ahead and enter that command with the sudo fdisk and the echoes as appropriate.
Gotcha. Okay, it says welcome to fdisk. Changes will remain in memory only until we decide to write them. Awesome. So what do we have to do next, Rishi?
So, yep, the next thing is we're going to need to write a file system to partition the disk. And we're going to use the command sudo mkfs to do this on SDC1 with the ext4 file system. So mkfs is just the Linux command for make file system. And we're going to need to, essentially use the super user sudo power as well to do this.
Okay, does that command look right?
Yes, it does.
Awesome. Okay, it looks like it's ready system for us right now. If I were to not use that sudo command or super user command, the code would have failed because this is kind of like an admin action that I'm performing. So we want to create a folder, right? How are we going to go and do that?
Yep. So we're going to create a folder called data and then actually mount that folder with the following commands. So what you're going to do is use the mkdir command, sudo mkdir, and that's going to make our directory and make it /data to create the directory as data. And then we're going to use the sudo mount command to mount onto SDC1 in the data directory.
Okay, forgive my slow typing skills here. Let's make sure I don't type anything incorrectly. So we've got sudo make directory data. That's going to make our folder, and then we're going to mount this folder in SDC1. Does that look good to you?
Yes, it does.
Okay. Well, the command went through, it didn't error out on me. So maybe we can try an ls block to see our different drives here. And it looks like SDC1 is now mounted, and you see that mount point as the data folder. So I think we should be good there. Now, the next step here, at the end of the day, what we're trying to do is deploy a VM that is going to act as a web server, right? At least a basic web server. So I think we need to update our packages, right? Is that the first step, Rishi?
Yep. So we're going to want to install Apache eventually, but the first step we're going to want to do is use the sudo apt-get install command, and that will essentially update our packages to the latest versions. Since a lot of these distributions are open source, we just want to make sure we're using the latest versions of all of these. And then once that is done, we'll actually be able to install Apache so that we can configure our virtual machine to run as a web server.
Gotcha. Awesome. So we've updated to the latest packages. And now, again, the reason why we've done that is this virtual machine image, let's say maybe it was published on the Azure Marketplace a month back, right? And Ubuntu, or Canonical, I should say, the producer of the image, is always updating the image with the latest and greatest binaries, right? So if we want to be on the latest iteration, the most stable version of this Ubuntu 18.04 image, we're going to want to update our packages before we do anything. It's kind of best practice. So we've done that. Now we want to install Apache, right? So what's going to be the command to do that?
Correct. So you're going to use the same type of command we just used and do sudo apt-get install apache2-y. And essentially the -y in this case is just going to accept all of the questions that are asked as a part of configuration.
Gotcha. Okay, so it looks like this is working. It's going to start downloading Apache for us here. Bear with us here, as you know, sometimes this can take a couple seconds, and it looks like we are done, right? Is there a way that I can check if it actually installed correctly?
Yep, using the sudo system control status command with Apache 2 no pager, you should be able to double confirm that this is installed and running as an Apache web server.
Okay, so I've run that system control status Apache 2 command, and it looks like I see Apache is running. So theoretically, our VM should now be a web server. No? Should we be able to access this from the internet?
Yeah, why don't we go ahead and try it out?
Okay.
Yeah, so as of right now, our virtual machine is acting as a web server. So if we go to the IP address of the web server, we should be able to get access to the web pages that are being put out by the web server. So why don't we go ahead and try this and see if we could connect to it.
Yep, and public IP is going to be located here on that overview page. So I'm going to go to my other tab that I have open. Let me paste this in here. And we should be able to access, unless maybe we missed an important key step here. It's looking more and more likely that we did miss a step because this is still loading. And Rishi, can you tell me what's going on here?
Yeah, so this is not going to work because there's one important step we missed as a part of our VM creation. So when we created our VM in our network security group rules, we only enabled inbound access via the SSH protocol. But now we're putting this VM as a web server, and we want to be able to access this web server through the internet, through HTTP. But right now, that is blocked as a part of our default network security group rules. So we're going to need to go back into our network security group rules and make sure that we enable our VM to have inbound access via HTTP over port 80 in order to enable this connection via the internet.
Gotcha. Okay. So we need to change our network security group settings, right? That's kind of the high level next steps.
Yep.
Okay. So should I go to this network page here then?
Yes.
Gotcha. Okay. So we want to, I believe we want to create a new rule. No? What do I need to do here then?
Yep. So as you can see, the SSH was already added in our network security group rules like we did at the beginning of our VM creation process. What we're going to do now is click that big blue button on the right side of your screen that says add inbound port rule. And we're going to make sure we add an HTTP rule so this web server can be accessed via the HTTP protocol as well.
Okay, sounds good to me. So why don't you walk us through the different options here? I don't think we have to change all of these, correct?
No. So the only thing we have to change here is the service, the fourth one down. So we're going to click the HTTP button.
Gotcha.
And as you can see, that auto-populated the destination port ranges to port 80. So a lot of
Uh-oh. Sorry, folks. It looks like Rishi may have lost connection here. Luckily, I can walk us through the rest of this exercise. Maybe if Rishi comes back, we'll be able to bring him back into the fold here. Oh, it looks like he's back.
Happened there, but looks like I'm back. Sorry. So I guess what I was saying was that each of these different protocols has usually some sort of dedicated ports that they operate under. HTTP is port 80, so it auto-populated that port to port 80. SSH was 22, so a lot of these will auto-populate to the right port depending on the protocol. So after this, we should be good to actually add the VM. Everything else should be the default settings, or sorry, add the security rule.
Okay. Wait, so for the priority, should we keep this at 310 then?
Yes.
Okay, gotcha.
That's the default.
Okay, so it says up at the top that we're creating this new security rule for us, and we called it allow any HTTP inbound. You could have changed the name, again, if you're following along with us, if you wanted to spice it up a little. But, you know, the reason why I asked about the priority, maybe we, thinking back to earlier in the content when we were talking about the network security group rules, the way you make rules, or the key identifying factor, at least one of them, is going to be the priority. So we talked about how HTTP is going to default to being in that port 80, just as SSH is going to default to port 22. And then we made this an inbound port rule. If we wanted to make an outbound port rule, we could go to the outbound section. But the way that this rule is going to be applied is based on the priority. So the lower level number, in this case, the SSH rule has the lowest number, that's the 300 priority. The lower the number, the higher the priority, and that's the order in which your rules are going to be enforced. So as we can see, this SSH rule is going to be enforced first. Following that, we have our priority 310. That's going to be the second rule that's going to be enforced. And then we have our three rules that we kind of talked about earlier, which is the default settings. We've got allow VNet inbound. This is going to allow your resources in the same virtual network to communicate with each other. We've got allow Azure load balancer inbound to allow Azure to talk to your VM. And then the lowest or the highest number, which is the lowest priority, is going to be the deny all inbound traffic. And this is the rule. The reason why we put this last is because it's going to go through the order of operations. It's going to assess all of the different rules that we've created, and then finally block all the other traffic, right? So if we were to delete this rule, you know, that would be an incredibly bad idea, because then we'd just be opening up our virtual machine to all types of traffic, right? And we don't want to do that, because there could be some malicious people out there that are trying to, you know, put some malware onto our virtual machine, or maybe even worse, right? So we've got to have that deny all inbound rule in there, which, as we've done with the default network security group settings, it's set that as the lowest level rule. So I think should we be ready to try to access that web server page again?
Yep.
Rishi?
So now that the rule is already here on the screen, we know that it's gone through, and we should be able to refresh the page, and hopefully our web server is enabled and accessible.
Oh, wow.
Perfect.
Okay, so as we can see here, our virtual machine, our ARM-based virtual machine, is now serving us the standard Apache Ubuntu default web page. Before, you know, we were getting an access denied because we didn't have that port 80 open. But now that we have port 80 open to HTTP traffic, you know, we can access our virtual machine in the pages that it's serving. So hopefully, you know, if you were following along with us in the sandbox or in the live learn module, you know, you were able to create your own web server VM and open the right port such that you could access that page. If not, I hope you're able to use the information that we've covered here and refer back to this video to try and deploy your own Linux VM and access it later on. But that kind of concludes the demo here. Rishi, did you want to add anything?
No. So I was just gonna say the same thing. So that's gonna be the end of our demo today. So as a part of our demo, what we did was we first created our SSH keys to be able to connect to our VM. We created our virtual machine, including the SSH keys to enable the public-private key connection. We were then able to mount our data disk onto our Linux as a Linux and file system onto Linux. And then actually create a web server based off of Apache to be able to host a real live web server as a part of this demo. So, as Noah mentioned, hopefully this was a very or you were able to gain some value out of this session and enables you to continue to use some of these as basics to build off of as you're building applications on Azure in the future.
Awesome. Okay, we do have a couple more check-in questions. Hopefully, the information that we've relayed to all of you has stuck. So why don't we go back to our slides if we can before we wrap up our session today. Is that going to be possible here? Hopefully it is. We'll see. Let me see what the next question is.
So we can
Seems
get
like we're having
slide up.
Oh, it looks like Rishi, you've got to share the slides again.
Oh, because I got kicked off.
He got booted off the stream, so he's got to reshare.
Right, 1 second.
No problem here. I'm gonna close out my screen so I'm not so bright. All right, so while Rishi's pulling up the slides, I'm just going to read the chat quickly. No problem, Rishi. We've still got, I believe, 14 minutes left, so we should be good on time.
So I think it should be shared now if we can go to the perfect.
Awesome.
Okay, so sounds good. So question 2. What is the effect of the default network security settings for a new virtual machine? Is it A, neither outbound nor inbound requests are allowed? Is it B, outbound requests are allowed, inbound traffic is only allowed from within the virtual network? Or is it C, there are no restrictions, all outbound and inbound requests are allowed? So we'll give a few more minutes or maybe a few more seconds for everyone to look at the security question. And again, you can find it in the chat as well as at aka.ms/polls-08. And we'll give it a few seconds for the answers to start coming in.
I think this is something that should be pretty fresh in everyone's minds, right? We just went over the network security group rules and what we had to change to access our web server page, but I know that it can be kind of confusing. There's outbound, there's inbound, there's inter, VNet, I get confused myself sometimes. So hopefully everyone was able to answer the question here. I see some votes coming in.
And it looks like everyone has gotten it correct so far. So Noah, why don't you go over the answer?
Yeah. So the correct answer here is going to be B. Yes, I see some answers in the chat as well. B is the correct answer. So like we mentioned earlier, outbound requests are going to be zero risk, right? This is the virtual machine communicating out with the outside world. There's no, how should I say? A bad actor is not going to be able to do anything with an outbound request. But inbound traffic is different, right? Inbound traffic, you're going to be able to access resources inside that VM. You could send a request, get a response, right? So generally, the default network security group is going to block all inbound traffic except for the ones that you say specifically you want to open. So in our case, when we deployed our virtual machine, we opened port 22, which is the port for SSHing into our VM, and then we were able to access it. If we did not set that port 22 to being opened, then we wouldn't have been able to access the virtual machine. So hopefully that makes sense to everyone. We've got one final question before we wrap up today. Question 3. So I'll read the question for everyone. You can access the question there at the QR code and the link, the same as the previous 2 questions. So Rishi, suppose you have several Linux virtual machines hosted in Azure. You'll administer these VMs remotely over SSH from 3 dedicated machines in your corporate headquarters. Which of the following authentication methods would typically be considered best practice for this situation? I know we covered this maybe kind of halfway through the presentation, so it might be stale in everyone's mind, but we'll wait a couple minutes. I keep saying minutes. I think everyone's going to be faster at answering than minutes. I see some votes coming in. It looks like most people are, in fact, getting it correct. So Rishi, why don't you go over what the answer is in this case?
Yep. So let's go through each option one by one. So for username and password, this is, I guess, the most basic of the protections for SSH. The problem with going with a username and password only is it's vulnerable to brute force attacks. So if someone were to create an algorithm and just keep trying to guess your password over and over, this would be vulnerable with just a password protection. The other option that we discussed was having a public key and private key pairing to connect to SSH, and that's definitely going to be the better option. So the private key, once it's enabled and set up within your local system, you're able to use that, and the virtual machine is going to have to attest to that private key, and only if that private key is exactly the same as it was for the public key combination will you be able to get into your VM. So that will enable you another level of protection. But the answer is actually going to be C here, which is a private key with the passphrase. So with the private key, public key protection, you're still a little bit vulnerable in the cases where a bad actor, someone was able to get a hold of your private key. And if they have your private key, they'll be able to get into your virtual machine. So having a private key set up with a passphrase gives you the most protections possible to make sure that you're also password protected, and gives you an additional protection there in case someone were to get a hold of your private key. And since there are only 3 dedicated machines in this example, it should be fairly easy to make sure that those private keys are stored on those 3 machines directly and can be used to make that SSH connection.
Gotcha. Okay, so I'm just reading over the chat here some questions on the YouTube stream that's going on right now. I think maybe I see a question from Ricardo asking why the secure key with the passphrase is going to be the most secure. So like we said, the secure key is going to allow you a scenario such that only the person with access to this key can get access to the virtual machine. With a username and password, on the other hand, anyone who knows the username is going to be able to at least try a brute force hacking method of trying to guess your password, right? And if your password is not necessarily the most robust, generally this is going to open you up to lot more risk than the case where you have access to this SSH key and only you can get in. And then with the passphrase, you're just adding that additional layer of security there. So hopefully that makes sense to everyone. That was obviously the last check-in question. So Rishi, did we cover kind of the summary? I think we kind of did already, but why don't you run through just quickly again everything that we've covered today, and then we can probably wrap up.
Sure. So thank you, everyone, for attending the session. So as a part of this session, we first covered all of the options that are available for virtual machines on Azure. We talked about when to use certain types of virtual machines for certain types of workloads. We talked about how to select your OS image and all of the considerations when creating your storage and networking profiles for your virtual machine. And then in the demo portion of the lab, we were actually able to go and create a Linux virtual machine in the Azure portal, connect to it using SSH, and be able to create a fully functioning web server, Apache web server that our VM was running as and be able to connect to that over the internet. So I hope this was a valuable learning session for everyone involved. And I think you should have the baseline knowledge to go and continue to develop using Linux VMs in the future on Azure to build any applications or workloads that you may want to in the future.
Yeah, thanks, Rishi. I just want to thank everyone for joining us on this journey today, trying to deploy a Linux virtual machine. Hopefully the information was easy for you to understand, and hopefully if you followed along, you were able to successfully deploy your web server virtual machine as well. We have a lot more courses on the Live Learn website that we urge you to check out. There's some, if you're a little bit more experienced with Azure, you can dive into those and learn even more about what's in store. But we just want to thank everyone for joining today, and have a great rest of your day and happy holidays.
Thank you, everyone.